welcome. So let's review operations with polynomials, including addition, subtraction, and multiplication. And we'll also learn some techniques to make multiplying a little faster. All right, so let's start off with a definition. A blank is a letter that can represent any number from a given set of numbers. Of course, that's a variable. There we go, finally started writing. Right, so sometimes, if we had a polynomial equation, our variable could be replaced with any number, right? The domain for polynomial functions are all real numbers. So a polynomial in the variable x is an expression of the form, right? So we have a variable raised to a power, right? And our powers, our exponents, are constants. And if it's in standard form, we start with the largest exponent and then we work our way down. That's all that's saying, right? And we might have a constant here, right? So this value here with no x is just a constant, right? So our polynomials can include a constant as well. And this is already in your notes, right? So the coefficients of each of our terms, and each of the variables are real numbers. Our exponents are non-negative integers, right? And whatever the largest exponent is also the degree of the polynomial. Okay? So the largest exponent equals the degree. If you have just one term, it's a monomial. And if you have more than one term, each of those monomials make up the polynomial expression. Note that the degree of a polynomial is the highest power of the variable that appears in the polynomial. All right, so here are some examples. Let's start at the bottom there with 6. 6 is a monomial. There is one term. It is 6. Its degree is 0, right? Because technically I could say this is 6 times x to the 0 power. Right? So its degree is 0. Right next to it we have another monomial, 9x to the 5th. Right? That's a monomial because there's a single term. Because the largest exponent, the only exponent, is a 5, this is a 5th degree expression. Above that we have 5x plus 1. This is a binomial because there are two terms. Right? There is the variable term 5x plus a constant 1. Since the largest exponent is 1, right? X without an exponent is understood to be x to the first power. This is degree 1. Next to, right above that, we have 8 minus x plus x squared minus 1/2 x cubed. If that were in standard notation, we would have the cubed term first. So it would be negative 1/2 x cubed plus x squared minus x plus 8. Because the largest exponent is a 3, this is degree 3, and there are 4 terms there. So we have monomial 1 term, binomial 2 terms, trinomial 3 terms, and we don't really have a word for 4 terms. Quadronial? We can invent a new word. Above that expression, we have x to the 8th plus 5x. That is a binomial because there's only 2 terms. And it's degree 8 because that's the largest exponent. And finally at the top there we have a trinomial, 2x squared minus 3x plus 4. 3 terms, largest exponent is square, so this is degree 2. And I decided to work from the bottom up just because I saw that little old 6 by itself, and it looks like he wanted to start first. No other reason. Adding and subtracting polynomials. So let's look at some operations. We'll start with addition and subtraction. We add and subtract polynomials using the properties of real numbers. The idea is to combine like terms, that is, the same variables raised to the same powers. Right? And if we have when we're adding, we add the coefficients. So if I have a 5x to the 7th plus a 3x to the 7th, right, I add the 5 and 3 because you can just think of that as 5 plus 3 times x to the 7th. Right? X to the 7th is being multiplied by both 5 and by 3. Those are like terms. We've got same variable x raised to the same power of 7. We can just add the coefficients. And you've done that before. The important thing is when you're subtracting, right? Remember when you're subtracting that it's essentially like multiplying by -1. You have to remember to distribute the negative sign to every term in the expression that's being subtracted. All right, so to remove the parentheses, if you have minus b plus c, don't make it minus b plus c. That wouldn't be correct. You need to subtract all of b and c. So you need to distribute that negative sign to both b and to c. That's the important thing to remember when subtracting. All right, these two are both in your notes. I just did 2 examples because I think that's enough because this is a review. Find the sum x cubed, I'm going to write it in, x cubed minus 6x squared plus 2x plus 4. Notice I have parentheses, but if I'm adding, I can drop those parentheses. So I'm going to go right ahead on the first step and just drop the parentheses. Plus x cubed plus 5x squared minus 7x. And all I need to do is combine the like terms. Right? So there are 2 cubic terms, x cubed and x cubed. We can add those together. That makes 2x cubed. Right? We've got 2 squared terms, negative 6x squared and positive 5x squared. Negative 6x squared plus positive 5x squared would be a negative x squared. We can combine the x terms. We've got a 2x and a negative 7x. So 2x minus 7x is a negative 5x. And there's just one constant, plus 4. And there we go. That's all there is to adding. You just add the like terms. And I'm sure this is review. Let's do the second one. All right, so we have x cubed minus 6x squared plus 2x plus 4. This time I'm going to write the parentheses because I need to distribute that negative sign. Minus x cubed plus 5x squared minus 7x. So before we can combine any terms, we need to distribute that negative sign to all of the terms in the second expression. Essentially, it's like having plus a negative 1. Right? So what we're doing is just distributing the negative to all 3 of those terms. So now I can drop the parentheses so long as I remember when I'm writing this to distribute the negative sign to the terms in the second expression there. So it's going to be minus x cubed and minus 5x squared. And now a negative times a negative is a positive 7x. And so now we can combine the like terms. We've got 2x cubes, but their signs are opposite. And x cubed minus x cubed is going to be 0. So that's the end of the x cubes. We've got negative 6x squared plus a negative 5x squared. They're both negative. Add those together. That would be negative 11x squared. We have 2 terms that included x. 2x plus 7x, that's going to be plus 9x. And again, there's that constant 4. And there we go. There we've subtracted the terms. Right? So the only difference between addition and subtraction is with subtraction, you need to remember to distribute the negative sign, right, before you subtract. Right? I'm going to pause here, and in the next video, we're going to look at multiplication. Thanks for watching. Bye for now.